Okay, welcome to lecture 6 of sequence. We're in the middle of learning sequence. Okay, sequence, remember I told you there's two big category. One is called sequence, where we learn the patterns, like 147, like patterns, and try to come up with a pattern for a rule for nth term, right? And another one is called series, which is summation, same thing. Okay, where you sum everything, right? And the sequence has two kinds. One, which we learned, is called arithmetic. The other one is called geometric. And today we're learning geometric one. We're learning geometric. Yes. Yay. Right. Okay, what is the difference? Well, very easy. Arithmetic one, you have A1, A2, A3, all the way to AN. Same thing here in geometric. A1, A2, A3, all the way to AN, where N is a number of terms. Now the difference is, arithmetic is a sequence where you add constant number from the first the term, okay? So if you add a common difference, get constant number, you get A2. There, you add the same number, you get A3, all the way to AN. What about here? Instead of adding, you times, okay? And we don't call that D. Here, we call that R, okay? So here is a D, difference. Here is R, which is a ratio. And it makes total sense because it's a multiplication. You times R here, you times R all the way. Now, we know how to find A3 from A2. You just add plus D, right? But we can find the other way around too, backward. How? Well, from A3 we can find A2 by minusing D, subtracting D, negative, minus D, right? So in just like that, we could find backward. Like forward, we times R, right? But backward, what do? We don't subtract, but we divide. Okay, so what do is we divide this by that. So A3 over A2 should give you the ratio, okay? The constant number that you're multiplying. Or if you have A5 over A4 should give you R as well, okay? Now, and that's a very good way to, you need to know this a lot. Why do we have to divide when we know we can? When we know it's a multiplication? Well, when you have 3, 6, 12, like 24, this kind of sequence, you don't have to divide. You know the R is times 2, times 2, times 2. But sometimes it's not that obvious. Okay, then you need to divide. For example, you have 4 and negative 1, and let's say you have 1/4, and you have negative 1 over 16. Now the R doesn't, all of a sudden it doesn't seem so easy to find, right? 4 times what gives you negative 1? Not sure. So that's why we need to divide it, okay? We need to divide negative 1 by 4. Okay, that will give you a ratio. So negative 1 by 4 is negative 1/4. So ratio is negative 1/4. But is it true here? Well, let's find out. So this divide by that should give you same thing. Yeah, 1 over 4 divided by negative 1 is still negative 1/4, right? Same thing. This one divided by that will give you a negative 1/4. That's why we need to know this. Now, so we are learning sequence. Okay, we're learning sequence. And there, like I said, there's two kinds: arithmetic. The other one is geometric. And we are here right now. So in this lecture, I am going to talk about how to find AN, okay, nth term. The next one, I am going to talk about the geometric mean. Geometric mean, what is that? Geometric mean is how do you find, like if you have like 4 and you have another number here, and then you have, let's say, 32. Okay, how do you find the one in the middle? We learned that in arithmetic, remember? Okay, how do you find that? So if you have like A, and then you have something, and you have C, How do you find this X? How do you find this X? Well, what you do is A plus, right? A plus C divided by 2 will give you X. Just like that, but this is arithmetic, but this is geometric. So we will learn that. And in the last part, we will learn the summation or the series. Okay, how do we add all of these geometric mean? But today in this lecture, we're going to talk about this. Okay, so let's go. So you have the sequence A1, A2, A3, A4, dot, 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 all the way to AN. Now, obviously A1 is just A. Now, here. How did A2, well, okay, it's geometric, so we have to times that constant number R. Okay, A times R is going to be AR, right? AR. How many times did you have to multiply R? Once. So exponent is 1, okay? So A3, okay, so the times another R, right? Times another R. This is in terms of, let me just color this way. This is in terms of the first one, because I'm doing arithmetic, the explicit. In terms of the first one, okay? So here, you have in terms of A, the first one, times how many more? R twice, right? So R and then square. How about here? In terms of the first one, A times how many R? You have to times another R. So R cubed. All the way to AN. So this A, and then we're going to R. But R, how many? What's the number here? Well, let's look at the, what do you call it? Relationship between the N. These are N, right? So 4 and it's 3. Exponent is 3, huh? 1 less. 3 and 2, 1 less. 2 and 1, 1 less. So N and 1 less, N minus 1. So this is the formula. Okay, so AN is R, okay, the first term, and the R, and R to N minus 1. To the exponent, to the power of N minus 1. This is the formula that we're going to be using. Okay? Now, I want to say something here. Okay? Let me erase. So, let me erase this. So, you understand that, right? So, let me write that again. So, AN, AN is, what did I do? The first term is A. This is the first term. Ratio, and then N minus 1. Okay. Now, what if your formula, because all sequence has a different formula, okay? What if your formula was AN is like 2 times 3, 2N plus 1. Now, when you look at this, if I ask you what is ratio, what is a ratio? R is a ratio, right? R is a ratio. For example, if you have 3, again, 6, 12, 24, 48, you know this R is 2 times 2. R is 2. So if I were to write AN, the formula AN for this sequence, AN equals, A is the first term, 3, and then R is 2, so I'm going to put 2, and then N minus 1. That will be the formula, okay, for this sequence, okay? And in this sequence, minus the N gets one bigger. Example, if this is 1, I mean, it cannot be 1 because it cannot be 0. But let's say, oh, I guess it does. Let's say if this was 2, right? And this 2. So if N is 2, the exponent is 1, right? Exponent is 1. Okay? If N is 3 minus 1, if N is 3, exponent is 2. If N is 4 minus 1, exponent is 3. So it is increasing one by one. Okay? So we can say the ratio here is R. But this one is a little different. You are tempted to say ratio is 3, but ratio is not 3. And let me show you why. So when N is 1, right? Exponent is 1. 2 times 1 is 2 plus 1 is 3. When N is 2, okay, exponent is 2 times 2 is 4. 4 plus 1 is 5, right? N is 3. Exponent is what? This is 6 plus 1 is 7. let's go one more. N is 4, 8 plus 1 is 9. Yeah? So it's not going 1 by 1. It's actually going 2, right? Increasing by 2. So here, the exponent, the ratio, this is hard, Christian. The ratio is not 3, but the ratio is 3 square. That's the ratio. This is the ratio. Okay? So if there is something like R is Pn plus Q, right? What is ratio here? The ratio is not R. The ratio is Rp, R to the P's power. This is the ratio. Just like here, the ratio was this. That's the constant. This is the constant, okay? That is kind of important to know. Okay, let's see. What do I have to cover? Let's see. Okay, I think that's it. Okay, so in the next lecture that I'm gonna be doing some questions. Okay.